Alright, so today we're going to talk about, quite an easy topic, recursion formulas. And I also get to introduce one of I guess an interesting thing that's more for competition and math contests. A lot of them mentions this, especially Waterloo. Anyways, let's start. So today we're going to try to find sequences, and we're going to try to use this by doing recursion formulas. So the couple lessons that we did before this, we all did, we did simple stuff like, let's say, get my pen. Well, let's say we had 2n. So with any function, let's say we had a function that's in terms of y of x, and we had it on 2n. So if you don't notice that whenever we have a function of f of x is equal to 2n, sorry, f of n right here. So you'll go ahead and have 0, 2, 4, 6. You're working forward. Alright, you're using a formula and you're getting the first term, you're getting a smaller term and then a larger term. Recursion formula, as its name, is quite the opposite and basically the recurve of this. We're using the term after a term. So we're using, let's say, if I had a term of tn, we're using tn to find out tn minus 1. That's what it is. As simple as it is. Alright, so let's go ahead and start with the first example. Writing an arithmetic sequence from a recursion formula. So write the first 5 terms of this sequence right here. Oh, I didn't give you the sequence. So term 1 is equal to 11, and tn is given off by tn minus 1 minus 4. Alright, so we can note that t1 is equal to 11. So t2 must equal to t1 minus 4, which is also going to be 11 minus 4, which is simple as it is, 7, if you don't believe me. And then this just goes on and on. So t3 is going to be t2 minus 4. And if you can't do simple math, this is pretty much simple math. So the first 5 terms is going to be 11, 7, 4. Sorry, not 4. What am I doing? 3 minus 4. Negative 1 and minus another 4 minus 5. Alright. As simple as it is, these are your first 5 terms. Now, on assessments, most of the times, you wouldn't be asked a question so easy. Clearly. This is a multiple choice problem at the most. So sometimes they will want you to go ahead and find the explicit formula for this. So they gave you the recursion formula. They want you to go ahead and find the regular formula. And you can do that, practice, and I'll give you the answer that fn is equal to 15 minus 4n. Alright, Alan, you can check this, obviously. So let's move on to geometric sequence. So note the difference between geometric sequence is multiplied by a factor, and arithmetic is adding a factor, just so you know. Just go ahead and do pretty much the same thing for this. So we notice that t2 is related to t1 in terms of negative 3t1. So essentially what we're doing is that we're going to multiply the term before it by negative 3. This is an interesting sequence because it introduces us an idea of alternating sequences. So as you can see, the first term we have positive 2. Second term we have negative 6. The term after that, positive. The term after that, positive. Negative. The term after that, positive. And you see that as we go away from this, we're going on a bigger distance. This is something that unfortunately, I only get to talk about in calculus. But it's interesting to see that our curriculum starts building it up now. So anyways, enough trash talk. T2 is equal to negative 3t1 which means it's -6. And then -6 multiply that by is 18. Multiply that by -3. Just calculator work on -54. And then times 3 and so on and so on. So your first few terms are going to be 2, -6, 18, -54, and I believe 162. Yep. So pretty boring stuff, and it's very easy. And I also want you to go ahead and find this explicit formula for this, which in our case, it's pretty easy. So we will have Fn. Wow, what's going on here? Fn is equal to ARN minus 1. So 2 is our A. Wow. 2 and our R is -3 and minus 1. And that is our explicit formula. Now, the lesson would have been over here, but it's too short. So they added something here that they want us to discuss about, the Fibonacci sequence. So, to your surprise, the Fibonacci sequence is actually discovered by an Italian mathematician named Fibonacci. So, the sequence is 1, 2, 3, 5, 8, 13, 21, 33, sorry, 34, my fault. And it just goes on and on and on following the current pattern. Now, if you go ahead and take a look at it, obviously we can write this in terms of a sequence, right? But is it arithmetic, or is it geometric, or is it neither? So I want you to take a moment to think about the properties of the Fibonacci sequence. And obviously I'm going to give you a little bit of time here. And I also want, on top of that, I want you to go ahead and see what is the pattern here. Okay. Alright, that was enough. So, the Fibonacci sequence, we look at it and we realize, hey, wait a minute, it doesn't have a common factor. We don't add the same every time. We added 1 on the first, 2 on the second, 3 on the third, and then suddenly we jump to 5. That doesn't make sense. And then we jump again to 8. Oh, wait a minute. That mentions something. From here we jumped 1. From here we jumped another 1. From here we jumped 2. From here we jumped 3. From here we jumped 5. So you can see that on top, using the differences of the Fibonacci sequence, I can derive another Fibonacci sequence. So we can see that every term together, they will add up to the third term. 1 plus 2 equals 3, 2 plus 3 equals 5, 5 plus 3 equals 8, 8 plus 5 equals 13, and so on and so forth. So this is actually not a geometric sequence, nor is it an arithmetic sequence. Now, this thing it's great because these numbers, they are something in a, well, they are classified when you take calculus. They will classify this sequence in calculus. But it's definitely crucial to understand this as you realize that this is a function. This Fibonacci function, it is a function that answers the question. And that's right. This is very important on contests. So if you're a contest taker, you have to know this. They usually test this by telling you, okay, the first 10 terms on a Fibonacci sequence is this, or they don't tell you exactly what it is, but they want you to not only give them the number, but multiply them by a certain magnitude, or you turn them around, flip them around, and do all that interesting stuff that they would usually do at a math contest. Yep, but that is all for now. I'll see you guys in 3 minutes after the break, and we will go on to our next topic.